Hello dears, welcome to today's session Mechanical Properties of Fluid. What is that? Mechanical Properties of Fluid. On this topic we will discuss some theory concept. After that we go for some important MCQs for the examinations like NDA, NSET, JEE Foundation. Okay, without wasting time. So here, what is mean by fluid? That we need to know. Fluid is what? Can you tell me what is fluid? Fluid is not here. It is a substance that has ability to flow. It is a substance that has ability to flow. The substance that has ability to flow. Ability to flow is known as fluid. Such as example is what? You can take liquids and gases. Their character must be ability to flow. So that is fluid. Properties of fluid, that is no shape. What are the property? First of all, what is fluid? Fluid is nothing but which has ability to flow. Properties of fluid, if you consider, that is it has no shape, no shape and size. Interatomic forces are weak. Interatomic forces, when you see solids, there is a closed plaque structure, so that is the reason they have a strong interatomic force. But coming to the fluid, they have weak interatomic force. This is interatomic, the force between two atoms, interatomic force. This we can consider first property. Second, interatomic force is weak. Coming to third property, fluid cannot withstand shear stress or longitudinal stress. Shear and longitudinal stress. That is about the stress character along the length. So these are the few properties related to the fluid. Fluid is nothing but it is liquid and gas. Both are ability to flow. Fluid is liquid and gas. When you check the liquid, liquid is incompressible. You can try yourself also. It is incompressible, whereas gas is compressible. You can take water in a balloon or means apply some force. Does it compress? No. But you can take the air like helium. You can see the balloon filled with the gas. You apply some force, then balloon size is reduced. So that is about the compressibility. Gases will be compressible, liquids do not compressible, so that they are known as incompressible. Okay, clear? Next, one more word related to the fluid, that is called thrust. What is mean by thrust? So thrust is nothing but perpendicular force. For example, I am using the stylus on my screen, that is in perpendicular manner. So this type of the force we can consider as thrust. Force exerted by liquid is always perpendicular to surface. For example, take a bucket of water. Into bucket of water, when we drop a stone, this stone is at perpendicularly to the surface of the liquid or fluid. Then this perpendicular force, when we drop a stone here, just imagine this is liquid. When we drop a stone here, this stone, it is perpendicular to the water surface, this liquid surface. Then this type of the force we called as thrust. What we call thrust. Is that clear? As you know very well, that is thrust is nothing but just like a force, which is about Newton. So coming to the pressure. Okay, now what is mean by pressure? So here pressure is what? Definition: thrust exerted by liquid or fluid. You can take fluid. Thrust exerted by fluid per unit area is known as pressure. So that P equal to F by A. P equal what? F by A. P equal to F by A, where F is nothing but Newton, area is nothing but meter square. So P equal to Newton per meter square. Force per area, that is Newton per meter square. Simply we can say pressure is inversely proportional to area. Newton per meter square is nothing but Pascal. In SI method we will consider as Pascal. Coming to dimensions, F by A, F is nothing but ml t minus 2, area is nothing but length square. So that area means what? Length breadth. So here we taken in terms of length L, breadth L, so that is called L square. So ml minus 1 t minus 2. So this is about pressure. Okay, clear? So pressure. So pressure is inversely proportional to area. So here pressure in a fluid is due to weight of the liquid above it. So we have a liquid, and in this liquid if you drop any object, because of that object weight you will get the pressure. So here that pressure, it depends on when you drop a stone in a fluid, that stone creating some pressure. So pressure, it depends on what factors? Pressure P equal to H rho G. So that pressure, it depends on depth. Height means here depth. Pressure depends on density. Pressure depends on gravity. Density, depth, gravity. Pressure, it depends on density, depth and gravity. Pressure increases with depth. Same level will have same pressure, independent of container of the shape. Pressure not depends on container of the shape, independent of container shape. Then what is Pascal law? See, Pascal law is about pressure exerted by liquid is transmitted equally in all directions. You can take some fluid or water in a container or in a balloon, blow the fill with the water, then make equal walls to the balloon. Then you observe that one, the water is pumping out from the balloon those who have equal volts with the equal intensity, so that from here that water is experiencing equal pressure. So that is the meaning. So here pressure is exerted equally in all directions. Pressure applied to a liquid is transmitted equally in all directions. Transmitted equally in all directions. Your bike, in our bike we have disc brakes. Now latest bikes will have disc brake. Disc brakes works on the principle of Pascal law formula, that is F by A, F by A. See here how much pressure we apply, the same amount of pressure will be applied here. So this is a simple logic. And so where applications are working for the Pascal law, that is about the hydraulic lift and brakes. Which brakes? Disc brake. In disc brake we using Pascal law. Next one, that's about the Bernoulli. What is that one? Bernoulli. So here, as per the Bernoulli, we know very well. Yeah, this is one. I'm talking about the principle related to the chapter. Okay, that is Bernoulli is what? Bernoulli is nothing but faster the fluid, lower the pressure, slower the fluid, slower the pressure. Means what? That is simple one. Bernoulli, it is dealing with the pressure characters. What characters? Pressure as well as the fluid movement. Fluid movement. Let me discuss. So simple one here they are given to you, that is about, just you can see that tube Bernoulli principle where it is applicable, that is about the aeroplane lift Venturi meters. There we are observing the concept of the Bernoulli. Venturi meter already in the pink color one, that is about the shape of the Venturi meter, which is indicating about the flowing conditions. Okay, clear? So here aeroplanes are working in our room, the calendar or papers are floating because effect of the air, and that is nothing but the concept of the Bernoulli. During the summer season, huts, top roof, or that is sheets, they are floated in the presence of the heavy air, and that is about the concept of the Bernoulli. That is about concept of Bernoulli. Even though uh, spray also working on the principle of the Bernoulli concept. Bernoulli concept. So here I will give a simple one definition. Don't worry. Bernoulli principle states that what it states that sum of kinetic energy and potential energy, kinetic energy plus potential energy here, kinetic energy potential energy per volume, potential energy per volume, incompressible, incompressible non-viscous fluid, streamlined irrotational flow remains constant. That means pressure head, energy head, density head are constant. Pressure, energy, density are constant in Bernoulli principle. That is the simple thing. Bernoulli principle thing. Pressure head, energy head, density head are constant, and that is about Bernoulli. So here spray, from the spray we call atomicizer or sprayer works on the concept of the Bernoulli principle. Dynamic lifts As you know very well, what is dynamic lift? Dynamic lift is nothing but aeroplane wing. Such as aeroplane wing, spinning balls motion will be directed by the dynamic lift. So here, so applications to the Bernoulli principle, you focus on application related to your NDA examination and insight. That's about the aeroplane lift, carburetor, and venturi meter. These are the concept applications of Bernoulli principle. Then what is viscosity? Viscosity is nothing but just you can take water. Okay, this is water and this is honey. You can see honey is how it is flowing and water how it is flowing. There is a typical behavior you observe, is it right, in the water as well as in a honey flow. So here this type of the resistant to flow or internal friction we called as viscosity. Internal friction is called viscosity. So resistive flow, the property resistive to flow is known as viscosity. Viscosity having viscous force depends on area. Viscous force it depends on velocity gradient. So after simplifying this one, you will get F is proportional to A dV by dx. Remove this proportionality, then you will get F equal to eta A dV by dx. This is called viscosity coefficient. So here honey high viscosity, water low viscosity. Temperature rises, viscosity decreases. If you rise the temperature, viscosity will be decreasing. Coming to surface tension. What is surface tension? Surface tension is nothing but it is a phenomena. Liquid surface behave like a stretched membrane. Liquid surfaces behave like a stretched membrane. So that is about surface tension equal to F by L. What is that? F by L. F is MLT minus 2. L is L. So that MT minus 2. So this is about the dimensional formula. Liquid surface behave like a stretched membrane. That is known as surface tension. Water is spherical shape because of water droplets are spherical because of surface tension. Capillarized because of surface tension. Insect like mosquitoes, flies, they walk on water because of surface tension. Okay, so these are some introductory points. Now without wasting time, we go for the MCQs because we started MCQ series for here. Okay, the first question, two vessels of different shapes contain same liquid to same height, pressure at base. So this is the question. So tell me the answer. Two vessels of different shapes contain same liquid, same height, pressure at base. So that is about, your answer is same liquids, same height, that is our pressure. Pressure depends on H rho G. So your answer is pressure depends on depth, density and gravity. Clear? Coming to question 2, dams walls are thicker at bottom because of. Why dam walls are thicker at bottom? So here value increases, pressure increases, density changes, gravity changes. So here the answer is pressure increases. What is that? Pressure. Dam walls are thicker at bottom because of pressure increases. If depth increases 4 times, what are the pressure? Depth means what? Height. So you know already P is proportional to height. Is it right? So depth increases 4 times, pressure also will be 4 times, so that it will be 4. Pressure is independent of, tell me, pressure is independent of, pressure depends on depth. Sorry. Pressure is independent of, tell me, come on. Yeah, just now it is depends on depth, depends on density, depends on gravity, but not shape. Am I right? Yes, very good. Then coming to next one. Mm, Pressure in fluid acts. So pressure in fluid according to Pascal that acts upward, downward, horizontal, so that we can take pressure in fluid acts in all directions. In a horizontal pipe, velocity double pressure. Okay. In a horizontal pipe, you can take horizontal pipe. This is a sorry. Where is that? In a horizontal pipe, a velocity double pressure. So that is A1 V1 equal to A2 V2. This is about the what we call, that is about equation of continuity. So here you are asking about the question. The question is asking about velocity double pressure is what? Velocity and pressure both are, as per this equation, they are opposite. So here, and velocity double and the pressure is off. So that, sorry, pressure is decreasing, opposite, no? So that a velocity is increasing and the, sorry, this is force multiplication occurs due to, so force multiplication occurs due to, force multiplication occurs due to what? So come on, tell me. Force multiplication occurs due to what? A velocity. Come on, make it fast. This is your day only. Come on, occurs due to which condition? Velocity, area, area, density, value. Force multiplication occurs due to velocity. Come on, velocity, area, density. Which one, tell me? So the answer is force multiplication occurs due to, you can take any one of them, that is about density is playing a role, area is playing role, and velocity, but the concept volume is not considered, because this is about the condition for dynamic fluid dynamics condition. So that is F equal to rho a v square. This is the condition we have, that is about velocity is quadratic multiplier, area is linear multiplier, density is linear multiplier. So here this is the condition, this is not the question. Occurs due to A, B, C. Small position, larger piston gives. Tell me, small position, larger piston gives. Small position, look at small position, larger, small piston, larger piston. Question is wrong. Small piston to large piston gives. I will check the question. Small piston to I think this question is small piston too. What we have hydraulic system, so that is about small piston will create high pressure, and this will create less pressure, same force, same less force, greater force. Small piston and larger, small piston, large piston. Question mistake. I think there is technical mistake. Hydraulic system concept. Okay, I will check. This is we need to study Pascal again. So small piston change and larger piston in a hydraulic machine. That is about greater force. We should use greater force. Okay, that is P proportion to F4. So okay, P proportional to F. Small piston acting on a large piston in a hydraulic system multiply forces based on Pascal principle. So your answer here, according principle, that is small force by small area is equal to large force by large area. So here we have to consider small piston, large piston. So larger force only. Larger force means what? Greater force. Okay. See, write one here. Because the formula is F1 by A1 equal to F2 by A2. So small force, small area. Large force, larger area. So this one only. Okay. When velocity increases, pressure. Tell me. When velocity increases, pressure. Velocity increases, pressure. Come on. When velocity increases, the pressure is, where is that? Does it increasing? No. Same? No. So that is about just now we discussed it. Pressure is opposite to the velocity, so that is decreases according to the Bernoulli. So narrow pipe will have narrow pipe, then velocity. In narrow pipe, just you can take a tube, water is flowing out, you press here, then what you will get? Come on. Increasing, decreasing, this is our daily activity experiment. We understood when we are placing finger near the tube, we will experience this phenomena. Which one of the phenomena? Come on, see, come on, make it fast. Check the answer and tell me the answer. Reply in comment. Come on, increasing, decreasing. See, when we reducing size here, that is about pressure is increasing. Bernoulli principle is based on what? Come on, Bernoulli principle is based on what? This type of the question will ask. Definitely the questions are not asking on definitions. They are asking about the simplifications like the energy conservation, so their basic principles. So they will ask which is conserved. So here already we define pressure energy gradients, is it right? So Bernoulli principle depends on, tell me, depends on momentum energy. No, we have pressure, this pressure gradient is constant. This is how we start. So that is about Bernoulli principle is a consequence of the energy. Venturi meter measures. What it measures? Venturi meter, just now we discussed the figure. Venturi meter measure what? Tell me. Make it fast. Oh, I will go. So that is about, come on yaar. Venturimeter is measure what? That is about speed. Is it right? Determine rate flow. Viscosity is what? Okay, I will go directly without wasting time. That is about resistor. Units of the viscosity. That is about Pascal second. Viscosity decreases with the temperature. For, come on, that is about liquids. Ideal fluid as. Ideal fluid as. Tell me. Ideal fluid has. Come on. Ideal fluid will have always zero viscosity. Ayyo. Surface tension is, just now we discussed, that is about F by L. F is nothing but Newton meter. So Newton meter, this one. Water drops spherical due to surface tension. Capillary rise depends on. Capillary rise depends on what? Capillary rise depends surface tension phenomena. Capillary rise depends on. Come on, tell me. Capillary rise. Capillary. Capillary rise depends on. Come on, tell me. Depends on temperature, pressure. Sir, no temperature. No? So capillary rise depends. We have a formula. Let me clear that one. H equal to 2t cos theta by r rho g. This is about the formula. Generally, the capillarized character will be determined. So capillary depends on radius. Come on, make this one. We can conclude that one. The phenomena, it is about the adhesive character. This question I have to check. Capillary depends on r. Okay, radius. Smaller tube rises. Smaller tube rise. This question is incomplete, but smaller tube rise, more pressure. Okay. If depth doubles, pressure is what? So just now we discussed similarly. Oh, sorry. Pressure is proportional to height. If depth is double, pressure also double. Fast fluid region as low pressure. Fast fluid region as low pressure. Streamline flow occurs at. This is, I have to think about. Streamline flow occurs at high velocity, low velocity. Just check high velocity or low velocity. So that is about streamline flow occurs at high velocity. What is that? High velocity. Streamline flow occurs at high velocity. Am I right? Streamline flow, where we will see streamline flow, we are seeing aeroplane, bullet train. They are the streamline characters, shapes. Is it right? That is the reason they move in different way. Is it right? Streamline flow, it is about the application of which one? Bernoulli character. Am I right? Yes or no? So that is streamline character. Even in our Bernoulli principle, it is related to what? Pressure rate, energy head, and density head, rho gh. Okay, and the last question, sorry, 24th question. So here Reynolds number decides what? Reynolds number decides, it is about dimension parameter that primarily determine streamline flow, turbulent flow, that is about flow type. And the last question, hydraulic brakes uses disc brakes, that is about hydraulic brakes. Okay, that's about Pascal. Okay, thank you.